Okay, folks. Thanks for joining. I'm Tim Titus, Chief Technical Officer and founder of Path Solutions. I've been a network engineer for over 30 years, so I've encountered a lot of weirdness in the network. I've learned how to fight the weirdness and find the problems, and I'd like to share some of my experience with you guys today. Um, so without further ado, let's dive in. So the first thing is what does packet loss look like? Depending upon your protocol and your application, it might be a user saying, gee, this web browsing is incredibly slow. A lot of times people might think, gee, that's due to not enough bandwidth. In some cases, if there's more than enough bandwidth, you have gigabit links all over the place, packet loss will cause incredible slowdowns because there's retries that have to happen, resets, and so that can end up leading to some really slow web browsing. Additionally, you can have sessions just completely disconnect and you have to refresh the browser or reconnect to your service to try and find out, gee, why is this thing dropping the connection every now and then? Another thing is if you're having audio or video problems with VoIP or UC, that means you have screen artifacts or the screen kind of locks for a second and then the video updates, or you have dropouts. Typically, you'll hear clipping. Users will sound like it, and then and so you have cut words, and that's due to packet loss. Also, you can have servers and services that just mysteriously disappear and then they reappear, and that's primarily due to packet loss, although it could be due to the service actually disappearing, service actually stopping, but in many cases, it's due to a failing of the network. So these are some of the ways that packet loss ends up impacting the network. Let's go through now is what causes packet loss. So there's a number of different causes. We're going to go through each of those in a little bit of detail. The first area is resource limitations. The traditional one people think about is bandwidth limitations. If you have a 10 meg link, you're trying to shove a gig worth of traffic through, there's going to be a lot of packet loss. If you have memory limitations, like a switch or a router that is a low-end device that says, gee, it doesn't have buffering configured correctly, it's going to end up putting those packets into a buffer, hoping to transmit them. But if it runs out of buffers, it's going to have to drop those packets and say, couldn't transmit it, sorry. Additionally, you can have network device CPU limitations. There are some older CPU-based routers that can end up having problems here where you're trying to stuff too much traffic through it and there's too many ACLs that it has to parse. And so the CPU can't deal with that amount of traffic and it ends up dropping traffic as a result. So these are resource limitations. A second source of packet loss is a physical layer fault. And that's either a failing network card. We've all had network cards go bad. We've all had switch ports that go bad. We put a little piece of tape on that switch port and say, hey, don't use this one, it's faulty. We've also seen cabling issues. You end up going into somebody's cubicle and you notice they have a Cat3 patch cord that should have been thrown away over a decade ago. Yeah, that could be a source of a problem. Also, fiber. People end up going into a wiring closet and they'll move things just a little bit, and that fiber gets turned just a little bit too tight beyond its minimum turn radius, and it starts having a packet loss due to the light degrading. Also, wireless. That's considered a physical layer fault, is that you have contention in a wireless environment. And so if there's too many users or not proper channel definition, you can end up having packet loss in that area. So these are physical layer faults. An additional source of packet loss is misconfigurations, MTU misconfigurations. If you have VPN tunnels that are operating on links that really can't have fragments, and it's going to attempt to fragment because it can't send a 1500 byte packet through, that can be another source of packet loss. There's also situations where if you fragment a packet, if one half of the packet gets delayed or out of order, it can't be reassembled. So it has to drop the entire packet, even though half of that packet was already received. Duplex mismatches still plague networks. Half duplex still plagues networks. And it's primarily because people just don't know that there's a misconfiguration and that you're having collisions. I think there's still the rare case. I still hear stories from folks where they say they thought it was a switch under somebody's desk and they actually found out it was a hub. So honestly, if you ever find a hub anywhere in your network, first thing to do, back over it with your car. It should not exist anymore. Unless you're doing spans or taps and you're looking for that as a cheap man's tap, they shouldn't exist. So the last area that can cause packet loss is sometimes a little confusing to folks, is protocol limitations. The big one here is out of order reception. So imagine if you have two paths to end up sending packets to a destination. The primary path is good, and it sends the packet through nice and quick. The secondary path is a little bit slower. It has higher latency, and it sends the packet a little bit slower. That gives you the chance of, at the far end, having packets that arrive out of order. In other words, you would get packet number 2, then packet number 1. If it's TCP, you can deal with it, no problem. TCP will reassemble that at the transport layer, no issue. The problem, though, is you have real-time protocols that can't reassemble that. Otherwise, sound like Yoda, we would. Thus, the packets arrived, but because the packet was out of order, it had to be dropped. So that's a source of packet loss that happens with real-time protocols because of the fact that it's real-time. So where can packet loss occur? And so packet loss can occur in a ton of different locations. The PC can end up having limitations, buffer limitations, CPU limitations, misconfigurations. The network card on the PC can have a network card failure, other problems here. You can have a cabling issue. You can end up having a bad network card on a network interface on the switch, misconfigurations on the switch, backplane limitations inside of the switch. And this problem just continues at every layer 1, layer 2, layer 3 along the path through every one of these devices, all the way up to and including the inside of the server, being that the server can't process the packets and it has to drop it. So every one of these will drop due to one of those reasons of resource limitation, misconfiguration, physical layer error, or protocol failure.